Hey Glovey, you ever wonder what keeps satellites like the International Space Station and the Space Shuttle in orbit? Once they get to a certain place in space, they just keep going round and round the Earth. But I also know about inertia. Moving objects have a tendency to move in a straight line. So what keeps them from just flying off into space? Oops. Well, it turns out that there is a balance between inertia and gravity acting on these satellites. Now we all know that gravity is the attraction between objects. How big that attraction is depends on the mass of the objects, or how big they are, and how far away the objects are from each other. Objects on or near Earth are caught in this attraction and are pulled down towards Earth's surface. So even if you throw a ball up in the air, gravity pulls the ball back down to the ground. But in space, all that seems to change. I'm sure you've seen pictures of astronauts floating around inside the space shuttle, and we all know astronauts don't float around here on Earth. So does that mean there's no gravity once the astronauts get in orbit? And what about way out there in outer space? Is gravity still important out there? Actually, gravity is still at work, even as far away as outer space. So what do you think keeps the space station or space shuttle from floating away into deep space? You got it, gravity. But if there's gravity in space, then why do astronauts experience weightlessness? And why do they appear to be floating around? I know, it's a bit complicated. So let's ask a friend to help explain it. Dr. John Bacon is an engineer at the NASA Johnson Space Center in Houston, Texas.
Well, hi, Evan. A lot of people ask me about why gravity seems to go away when you get to orbit, and I can explain that with my keys here. I have a little elastic on the keys. I want to show what happens when I drop this whole system. The elastic is all stretched out, and gravity is the most important thing in setting up how my keys behave at the moment. But the instant that I let it fall, gravity's not going to be important anymore. It's not going to fight against my fingers, and you'll see this whole thing change in 3, 2, 1, and you'll see that even before the keys hit my hand, this little elastic has immediately relaxed. I've changed the way the keys behave when I let it fall. Same is true with water on the surface of a table. It has a nice flat surface for days and days and days until it finds the edge of the table and is allowed to trickle off, and instantly when it falls, we get surface tension taking the water into a nice little cylinder, and then air forces start shearing it into drops, and you see it do anything but stay flat. So when we take gravity away by letting things fall, we get a whole new behavior. And the problem is, here if we get high above the planet Earth and we want to start falling towards it, no matter where I go around the equator, I will fall to the middle of the Earth, and then I'm going to hit the Earth rather hard. So if I want to get this wonderful experience of falling forever, what I need to do is go sideways very fast. And if I can go sideways fast enough, I'll actually fall right over the horizon. And I'll just keep on going sideways with the center of the Earth pulling me to the middle. Now, if I'm on board a shuttle or a space station out here up in the vacuum, I'm going to feel like I'm falling forever. And so everybody on the station and all the experiments with them appear to float in the middle of the cabin forever. Notice that there's actually lots of gravity there. It's what's holding the space station right next to the Earth. Gravity is all the way out as far as the moon. It's what holds the moon in its orbit around us. But when we get going sideways fast enough, we just keep falling.
Just like skydivers, astronauts experience weightlessness as they fall towards Earth. So even though gravity's constantly pulling them down, they can't feel their own weight as they're falling. If there are two skydivers falling together, then it seems as if they're floating towards each other. Hey, don't I know you? But what keeps the space shuttle from falling to the ground like the skydivers? Well, like Dr. Bacon said, the space shuttle would indeed fall if it wasn't traveling so fast around Earth. How fast does the shuttle actually have to travel to stay in orbit? The shuttle is flying approximately 28,000 kilometers per hour. That's 17,500 miles per hour. That's so fast, the shuttle makes a complete orbit around Earth in just 90 minutes. Can you imagine that? So, the astronauts are being carried with the shuttle as it orbits Earth. At the same time, Earth is pulling on the shuttle and everything inside. But because the shuttle is moving sideways so fast, the astronauts and anything else that isn't fastened down are getting pulled to the middle of the shuttle, making it look as if they are floating. and that same sideways speed keeps the shuttle itself from falling back to Earth. I bet you're wondering how the shuttle ever comes back to Earth if it's traveling too fast to fall to the surface. The answer is simple. They have to slow the shuttle down. The shuttle commander actually fires the shuttle's thrusters in reverse. This slows the space shuttle down, and because it's no longer traveling fast enough to stay in orbit, the shuttle falls into the atmosphere and begins its journey back to the surface of the Earth. Gravity sure is complex, and every time astronauts travel into space, NASA learns more about this special attraction that keeps all kinds of things in their places, including us. Do you think you'd like the feeling of floating forever? I don't know. I think it'd make me a little sick to my stomach. I think I ought to rethink that whole skydiving thing.